Hi guys, welcome to Learn Electronics Repair and part 2 of the Universal Op Amp and Comparator Tester sponsored by PCBWay.com. I was really surprised at the reaction to part 1 actually. A lot of comments for you guys, thank you very much for getting involved, some useful ideas here. So I've moved forward a bit with this project. And I've discovered a few more things while I'm working on this, which actually makes this easier to build, especially if you want to build the Ghetto version on Vero board. But in this video, let's look at what I've discovered. Let's look at how we can test comparators as well as op amps. And then we'll move on to the PCB design, get a PCB layout sorted out, and then get that uploaded to PCBWay.com. So the first thing I looked at today was the comparator test circuit. If you plug a comparator into the existing tester, which we tried in the previous video, nothing happens. The LED doesn't light up at all. Now, I was a little bit surprised by that. I'm thinking, what is the difference really between an op amp and a comparator? Because basically they're doing the same thing. An op amp can be used as a comparator. Okay, I accept that comparators are optimized, as they say, for that purpose, but really, why does it not test comparators? And I had a look for a test circuit, and the one I actually found was this. So this is the test circuit from open source hardware, and at a glance I could see it's fairly similar to the one that I have. I spotted the capacitor, these two diodes, the resistors, and it looked a similar sort of thing, but I thought, well, obviously it's different in some way. This is a bit of a strange schematic, because if you look at it, pins 5 and 6, which is the inverting and non-inverting inputs to the second comparator in here, are not connected to anywhere. They don't go anywhere. But the output, LED 2, goes to here. So I'm thinking that can't be right. Yeah, so let's have a little bit of a look at this. And here is a schematic we were just viewing. You can see. Okay, so it has two LEDs. What I looked at here was the layout. Now, I can't get it enlarged very well, but do you see on this layout there are two blue tracks going under the chip? Yeah, do you see them there? And these are going from pins 2 and 3, which are the input on this side of the comparator, to 5 and 6, which are the input on the other comparator. Do you see that there? So it looks like basically they're using the same resistors capacitor network to test both of the comparators like in parallel together. Now, I don't like this design. First of all, because if you have a fault on one side of the chip, you wouldn't know there wasn't a fault on the other side. Okay, it's faulty, fair enough. But the original tester I had for op amps would actually test the two op amps in the package individually. You can see which one was failing. Okay, so I don't like that about it. Plus, we want to be able to make a quad comparator version of this, and we want a single comparator version. So I decided to have a look at the circuit and how this actually works. And I based it on here. I took out all the stuff for the second comparator, so just looked at this one effectively. Okay, and what I came up with is this. So in actual fact, the circuit is the same as the op amp tester. The only difference being that the op amp tester drives the LED. So it puts voltage on the LED. The other one's connected to ground. It's connected down here. And this version actually sinks power. So the power comes from VCC into the LED. So this is switching the LED on by effectively grounding this end of it. Whereas the op amp tester is switching the LED on by supplying current to it. You see? Everything else is the same. And I thought, well, that must be something to do with the output of the comparator ICs. So I thought, well, if that's the only difference, if we put a switch here, single pole, dual throw, the output can either be set to sink current or to source current. Yeah? And you can switch the switch in the up position to test comparators and in the down position test op amps, and therefore we don't need 4 of these for testing op amps and 4 of these for testing comparators. We just need 4 of them and switch the output. So I built this on breadboard to see what it actually does, and here it is. Let's try it. So at the moment I have a comparator chip in, LM393 dual comparator, okay? But I'm only testing one side of it. I've only built a single instance of this circuit. I just want to see what it does, okay? I've put the 2 LEDs and I've attached a switch, okay? So with the comparator, if we switch this on, you will see that the LED is flashing, okay? We have 1 LED flashing. This is the one which is connected, like I showed you in this circuit, the things behind this one, okay? If I switch the switch the other way, which is that, then the green LED just comes on and stays on. It doesn't do anything, okay? Now the fact when I switch the switch the other way, so that this is now sourcing current, the green LED comes on, surprised me somewhat, because I didn't expect that to happen. I did expect this to flash. I didn't expect that to come on. So let's have a look at how the output stage of these chips actually works. And then let's figure out why the green LED comes on. Quite dimly actually, but it does illuminate. This is our LM393 datasheet. And you'll see that the output stage is actually open collector. So this can't provide any current. All it can do is switch this transistor on, and as we have on ours, for example, a resistor through an LED to here. When it pulls this down to ground, the LED switches on. So this can only sink current. Same with the LM339 or 139, there's various chips which are compatible. It has the same output stage open collector, so again this can only sink current. And the same with the LM397 single comparator. This you can see has a pull-up there, pull-up resistor. That's for the same reason, okay? So the comparators can only sink current. That's why on the op-amp tester they didn't do anything. Why does the green LED come on and stay on dimly when I switch the switch the other way? Because it looks like the output of here, pin 1, is now providing current. But we know it can't do that. And in fact it isn't doing that. But we do have a current path. So via this 10k resistor and this 4k7 to the output, we have a connection from VCC. And although the resistances are quite high, 15k, it's still enough to light the LED dimly, and that's why the LED is coming on when the switch is in the down position. This isn't providing current, it can't. That bit of the circuit is. Okay? Let's put an op amp into our comparator tester. So with an op amp, the output can actually source or sink current on most of them, at least the ones I know of, okay? So if we take the comparator out and we put our op amp in, LM358, okay, power it up, and now the green LED is flashing, much brighter by the way, notice, because the op amp is now driving it. And in the other position, the red LED flashes. So the op amp will actually work in both positions. Yeah. And that leads us to an interesting choice. So we could take out this bottom LED and the resistor and the switch. Okay, just leave that one wired in, and then in actual fact this will test both comparators and op amps on the one circuit. Okay, and we just replicate it 2-4 times. We can do dual and quad. So our tester circuitry now is very, very simple, and we could do that, but I think it's advantageous to leave the switch in, and we'll need a 4-pole changeover for 4 circuits. Leave the other LED and resistor in, and then we can test whether an op amp, which should be able to, can both sink current and source current, because you could have a fault situation where it only works in one way but not the other. So I think it's advantageous to actually leave the switch in and the additional LED and resistor. And then we can, if we want to, label this as comparators or op amps, or I would probably label it as sink or source. So it either is sinking current into the op amp, or it's sourcing current from the op amp or comparator. And as long as you know what is going to happen with a particular chip, and the datasheet will tell you if it's open collector or not, I think that is probably the best way to go, because it's possible, as I say, to have a fault where it can only sink or only source current. But what do you guys think? And what do you think about that? For me, I'm going to include this on the PCB, and then, to be quite honest, anybody building this, you have the choice to include it or not. Okay? So for those of you who actually want to build this on Vero board now, this was the red LED, this was the green LED. This wasn't a 1K, it was a 3K3, and this was also a 3K3 resistor. As I discussed in the previous video, this just reduces the current. Okay, so all you really need to do is build 4 of those, and you can test any of these types of chips, to be quite honest. One other thing I noticed while I was just working that out, this chip, the LM397, and I suspect there are compatible chips with this, comes in this package, SOT23-5. Okay, now I think we should add this as an option on our board, have some exposed pads so we can hold one of these against the pads as well and test this type. Okay, I think we may as well do that. While I'm developing this, if you guys think of any other common packages that we should include on the tester PCB, just let me know. But of course, remember, we're including one of these, so I don't see why we can't, if we want to, have some sort of little adapters or just plug in and you hold your SMD or whatever device against that. Okay, so now we have that, I'll sort out the schematic. Let me get that drawn. So we continue, guys. We see we have Detlef with us again. Okay,
hey guys,
thank you, Det, for your input once again. So we know we're building 4 of these circuits, and then we're adding the sockets which we can use to test the op amps and comparators. So if we just go over and have a look at what we've designed so far, we now have the schematic drawn. So you can see here we just have 4 modules that we've called them, which are those little circuits repeated. And the switch here, you can see we've used net names. So this just switches the LED, so the op amp or comparator is syncing or sourcing. So, for example, we have switch 1 red for the red LED, switch 1 green for the green LED, and switch 1 out is coming from our module. And that's just repeated 4 times. Basically, all of this is just repeated over and over again. And the only other thing we have here is the actual power supply. So here is our constant current source with the switch, and the power terminals where we connect to our bench power supply. So that is the schematic for the modules, if you like, which we use to test our op amps and comparators. The other thing we need is the connections to our devices under test. So you can see here, we've made it nicely organized. So for single op amps, we have the dual inline 8, the normal 8-pin type you fit into an IC socket. This is the surface mount, SOIC 8. And this is another package we find quite often with single op amps, which is SOT23-5. So that's another surface mount. We did the same for the dual. So we have the surface mount, the normal dip, and the single inline package. And then this is the connectors to our breadboard, which will go in the middle of our PCB, so we can lash together basically the connections to test anything which doesn't fit into these pinouts. We then have the quad op amps. So again, we have the 14-pin socket and the 14-pin surface mount. And we also included a different pinout. This is for the quad comparators. The reason being, if you look at the data sheets for the dual op amps and dual comparators, they're the same pinout. But with the quad op amps and comparators, they're not. So the quad comparators, at least LM339, which is a very common one, has all the 4 outputs at the top. So that's basically the schematic. If we now go over to the layout, we can have a look at it. And here it is. So you can see again, basically we're repeating 4 times, okay, for each of the 4 modules. And these are our rows of sockets, if you like, or pads where we can test surface mount devices. Jack, can you show us what that actually looks like in 3D on the...
We have this fancy 3D view on this.
That thing?
This PCB stuff, this layout software here.
Okay.
And this is our current state of the thing. So don't think these like LED chips. These are sockets.
Yeah.
And we didn't do a polishing step here because you already see U5, U6, U blah blah blah. Because this will be changed into something that's more readable. So this will be called single, dual, and with all the naming schemes you already saw on the layout.
And our little breadboard that you see here, okay, that sits here in between these 2 rows of pin headers. Well, not really pin headers, they're like little sockets for DuPont leads. So we can actually just stick this onto the middle of our PCB here. And if you have some device that doesn't match the standard pinouts we've used, you can literally just connect the leads to where you want.
Yeah, these will be the pinouts for the pin headers. These are the 14-pin headers. We did something here where we think this is a more logical way. So VCC and ground is on the opposite side, and then this 1, 2, 3, and 4. So if you have something very exotic that doesn't fit into the normal layout, this is a way to connect this. Just stick a breadboard on the PCB and use DuPont wires.
Yeah, and we also decided to put one of these headers on either side of the breadboard. That's just make it easier for you guys to wire something together.
Yeah. The next logical thing would be routing.
Now, I have a theory about this. Detlef hates the auto router. He says it doesn't work.
The one thing with auto routers, never use the auto router.
Okay, now I said, well, in the case of this tester, first of all, it's very low frequency. It's flashing at like 1 hertz or something. So there's no high frequency signals on here. Number 2, there's no high current tracks on here. Nothing's passing any current as such. So wouldn't the auto router be able to do this anyway?
Never use the auto router.
Well, I'll tell you what, let's see if Det was right, or let's see, due to considerations I made, I was right. Let's see what the auto router thinks of our PCB.
And actually, we can do this before we do the final cleanup, because tracks won't be visible because silk screen.
Okay, so how do we auto route that?
Oh, let me see. I never use the auto router.
I think we...
Because never use the auto router. Let me see. This is
I think it goes under design or
auto route.
Auto route.
Yeah, there's auto route. Okay, let's try to figure this out. Real time, yes, please. We use a cloud. We can install a local auto router. We go for all layers, top and bottom layers.
So this is a dual-sided PCB, double-sided.
Yeah. You can add blah 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 blah. Okay, never tried this before. This is the first. Really, this is the first. And run.
Yeah. Please make sure all objects with net inside the board outline.
Okay.
We need a board outline.
Oh, this is the easy part. Okay, we simply give it an outline now.
So we draw a box.
Yeah. No, I can set the board outline automatically.
Okay.
And you want to have round the corners?
I don't mind.
Oh, let me get back to Mills, because Yeah, the German once mills here.
Okay. There's 1/1000 of an inch.
Yeah, that board outline, and go for, say, something like 25 mil. This always looks like
Okay.
rounded corners.
Okay.
And go, and now it drops the box here.
Yeah.
That would fit, because this is a bit close, but I think this is ground anyways.
Yes. Looks like it.
Yeah, so we're fine. We'll be fine.
We'll be fine. Come on, Auto
We'll be
Router,
fine.
do your thing for us.
Crap. All right, real-time display and run. Checking local auto. Oh. No.
Cloud.
And run. Auto router is running.
Look at this. It's done it. Almost. Thinking about it.
This is a nice test, and I already see things that I hate.
But will it work? This is the question.
Hate. Really much hate.
It's thinking about it. It's moving things around. It's having a think about different ways to do it.
So horrible things here.
Well, that's how it's still thinking.
This is horrible. So much pain.
Okay. It's still.
The thing here is cleaning this mess up. This auto routing up will be probably
Okay. It's done.
100%. It tells you
56 wires.
56 wires.
But does it really matter?
Well, from a production point of view, from a price tag point of view, it doesn't matter, because wires aren't something that you pay more
Can we
for.
zoom in and see what it's actually done?
Yeah, but look at this mess. Please, look at this mess. Look at this track here.
Where?
Wang, 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 wang.
Well, what effect would this have on the performance of the
Look
device?
at this. Look at these.
Yeah, I see.
You see the first thing I want to do is doing that, because I don't need this tight spacing here.
Okay. So maybe you can use the auto router and just tidy it up a little bit. I mean, will you take on board what I'm saying, because it's all very low frequency and there's no current?
Yeah, probably, but oh man, look at this.
I mean, the current limiter sets the maximum current for the whole board 50 milliamps.
Yeah.
It can't draw more than that.
Is this right? Did it do this? Did he do this right? Yeah, he did. All right. This will probably work. Again, this is first thing I've seen this. This is live. We're really testing this out for the first time now. And yeah, it's faster than I could do that, of course. But at the same time, I feel so much pain when I look at this.
You feel so much pain looking at this, yeah.
Well, it's your board. Your decision if we want to use this.
Well, here's my my professional opinion. Would you rather sit around now and reroute this yourself, or do you fancy a beer and a burger?
Yeah, beer and a burger sounds way better. Yeah, of course. But
and if we think it will work, I mean, you can drag a few things around, but
this is what I meant. Cleaning this up will probably take longer than. Oh crap! And now I'm already starting to move stuff around. So let me go to
Control Z.
Control Z.
Put it back. Put it back where you found it.
Yeah. I mean, who does this? Look at this. There's so much space. You could use easy way this way.
You could.
Yeah.
Shall we leave it to you guys to?
Oh yeah, let's hear the opinions of you guys of auto routers.
Okay. So what we're going to do, guys, we're going to send this Gerber file. Let's make a Gerber. Let's upload it to PCBWay. And we'll leave it to you guys. I won't place the order till after the weekend, so you guys can have a look at this and give us your also professional opinion. Are we better manually routing this, or are we better with the beer and the burger?
Thanks, mate.
Guys, just before we have the burgers and beer, we've put the silk screening on. So we can now see this is the power module. The switch is marked 20 milliamp or 50 milliamp. These four modules have our red and green LEDs, so this indicates what's happening with the op amps inside the chips, 1, 2, 3 or 4 of them. The switch can be set to sync or source current, as I described earlier in the video, so we have that done. And then these are the test areas. Like Detlef said, these will not be populated with chips. These will just be exposed pads where you hold the components you want to test against, or these will be 8-pin sockets, 14-pin sockets, and once again the breadboard, and this is where we can connect the DuPont leads. This one is for the 8-pin dual op amps in the single inline package. So that's all there now. So all we really need to do now is upload the Gerber file to PCBWay.com. Let's do that right now. Okay, so I'm logged in on my account. We're now at PCBWay.com. Let's order our PCBs. So we go to PCB Instant Quote. We go to Quick Order PCB. And we go to Add Gerber File. So this is the Gerber file produced by our design software. And you can use any PCB design software you prefer to do this. We now have our board. You can see the board there. Okay, all that we really need to do now is tell them what colour we'd like this in. I think we'll go with black because the silk screen will look very nice with white silk screen against black. I think that'd be very visible.
Use a thinner PCB. This is 1.6 mil, so this is something.
Okay.
I would go for 1.0.
1.0
yeah, this is my normal
PCB.
choice.
Although I've actually set for black with white, it doesn't actually show you that here, to be quite honest, but they will be supplied in the colour I've requested. So now I just save that to my card. Agree. And that's it. What will happen now is PCBWay will check that Gerber file over, make sure there's no production problems, and if that's all okay, then we're ready to go and it will turn up. Okay, so it's as simple as that, really. Hope you enjoyed that. It's definitely time for some food now, yeah?
Yes.
Okay, so maybe you guys will get your own burger and beer. Afraid it's not on us this time. If you're ever on your way to Gran Canaria, maybe it will be. Okay,
right.
Yeah. Thanks for watching. Ciao for now.
Ciao for now.